class, in today's lesson we're going to be solving quadratic equations by completing the square. The learning intention of this video is to understand that completing the square can be used to help factorize a quadratic equation when integers cannot be found, to be able to solve an equation using the completing the square method to factorize, and lastly to recognize a form of a quadratic equation that gives no solutions at all. So first, I just want to remind you what completing the square is. So completing the square is a way that we actually factorize an equation when the product sum method doesn't actually work at all. And by factorizing it, this therefore allows us to solve the x-intercepts for a given quadratic equation. And lastly, the reason why it's really important is because that we are able to therefore find out the turning point by converting the standard form into the turning point form, okay? So just to give you an example of this, for instance, if this was my equation in the standard form, if I was completing the square, this allows me to convert that into the turning point form, and as you can see over here, I can therefore readily identify what is a turning point. In this case over here, your turning point would therefore be equal to -4 and -19, okay? And in order for us to go from the standard form into this factorized form over here, what we need to be able to do is we need to be able to recognize as well as factorize perfect square trinomials as well as differences of perfect square. So just to jog your memory, a perfect square looks something similar to this over here. So in this case over here, when you find a perfect square, this number over here, when you multiply it by itself, that should give you the last term. And if you actually double this number, then that should give you the middle term over here. Whereas the difference of perfect squares, just two perfect squares are separated by a subtraction symbol. So when you factorize it, it should look like in this particular form over here. So I'm going to go through this example over again just to help you guys see how we actually do this. So in this case, what we need to do is we need to find our b term, we half it and then square it. So in this case, 8 is our b, so we're going to get 8 divided by 2, and that's going to give you 4, so 4 squared is going to equal to 16. What we do is we add and subtract by 16 to our equation, okay? So by adding and subtracting, we're not really changing the identity of the equation. It still remains the same because plus 16 and negative 16 cancel each other out. But by adding and subtracting, what this allows us to do is we can therefore factorize this perfect square trinomial. So in this case over here, you should be able to readily factorize the first three terms, and this would be x plus 4 whole squared, and then you just write the remaining terms towards the end. And therefore afterwards, your next step would be to simplify negative 16 and negative 3 in this case. So if you do that, therefore this would give you negative 19. Notice after we've completed step number 2, we have already converted our standard form into the turning point form. However, for the purposes of this question, what I'm trying to show you is how we actually factorize it. So we need to do step number 3. So in this case, if you notice how both of these terms over here are very similar to how it's represented in a difference of perfect square. So what we're going to do is we're going to factorize it like such. So find out the values of a, find out the values of b by square rooting both of them. In this case, if you're always going to usually get a surd, generally speaking, when you're completing the square, and therefore substitute it into this particular formula over here, and hence this is going to be our answer, okay? So I would like to reinforce that completing the square is essentially a way that we factorize by adding in additional terms so that we can form a perfect square and then factorize it as shown over here to this step over here, okay? I'm going to show you another way of how you can actually understand what completing the square is, and I'll show you this using a visual approach, okay? So in this case over here, this is a visual way or a geometric approach for you guys to understand what complete the square is, okay? So in this case over here, x squared, that's kind of like the area. So this is x, that's x, multiply them together, that's x squared. And I've got the areas for each of these terms on over here as well. Now, I'm going to show you something quite special, okay? What I'm going to do deliberately is I'm going to half my green rectangle, okay? And when I half this, what I'm going to do is I'm going to add these two green rectangles to my blue square. And I want to show you why we do this, okay? So in this case over here, once I've done that, can you guys kind of see that this particular square that I have on the left-hand side of the equation now looks almost identical to the square on the right-hand side? When you're completing the square by factorizing, what you're doing is you're trying to find out what this missing gap is. So you're going to add in an extra term, but we can't necessarily just add an extra term to an equation whenever we feel like it, okay? Whatever you do to one side of the equation, you must do to the other side since an equation is already balanced. So in this case over here, you're going to be adding both terms to each side of the equation. Now, what would that look like in terms of like algebraically? So in this case over here, when I'm adding a term, I'm going to be adding 1 to both sides of my equation. You're probably thinking, why am I adding 1? Now, in this case, you're doing the exact same thing. You're going to be adding it by b over 2 squared. So in this case, b is 2. 2 divided by 2 is 1. 1 squared is 1. Okay, so in this case, I've added 1 to both sides of my equation. And notice once I've done that, I could easily factorize this quadratic trinomial. So that's going to be x plus 1 whole squared. 15 plus 1 is 16. And as a result of that, I've actually just completed the square, but using a different approach, this visual method over here. Okay, guys? So what I've just shown you are 2 different ways of how you can actually factorize by completing the square, okay? And it's up to you which method you prefer, okay? The beauty of maths is you can actually take many different approaches. If you're more of a visual person and this method works better for you, then please adopt and use this approach. Otherwise, use the algebraic method that we've been doing in our previous lessons, okay? So, because there are 2 different ways you could actually factorize, similarly, there are also 2 different ways of how you could actually find the x-intercepts by completing the square. So once you've completed the square, you've got the choice of therefore using the null factor law, okay, and then equating each of these factors to 0 and then rearranging. Or alternatively, you could actually use square roots, and I'm going to show you both methods, okay? So I'm going to show you this particular method over here, and this is like the textbook method. So this is a method that would probably make more sense because we've already done lessons on how do you factorize by using completing the square. So in this case over here, this is my example, x squared plus 4x plus 2. Notice in this case over here, you can't factorize it using the product sum method because there's no 2 numbers that's multiplied by 2 that adds up to 4, okay? So we have to use completing the square. First step, we're going to go b, half of b, and square. So in this case, that would be 4 on 2 is equal to 2, 2 squared is equal to 4. And therefore, what I'll do is I'm going to add 4 and subtract by 4 to the left-hand side of the equation. So therefore, this is what my equation would look like. And now, once I've done that, I could easily factorize the first 3 terms. I've got to write equals 0 over here, but it doesn't make a difference. Therefore, my equation is going to be x plus 2 whole squared minus 4 plus 2 equals to 0, okay? And once we've got that, then what we'll do is we're going to simplify this part over here. So that's going to equal to negative 2. And once we complete that step over there, then what we could do is we could therefore factorize it in the form of a difference of perfect square. So therefore, if you do this, this is what you should get as your answer. Okay, and now lastly, which is a bit new, okay, from our previous lessons. Now we're going to use the null factor law. So all we do is we equate each of these 2 factors to 0 and then rearrange solve for x. So that's what I've shown you over here. So therefore, if you were to rearrange it, simply all you need to do is just pretty much invert or flip the sign. So in this case, x is going to equal to negative 2 minus root 2, or x is going to equal to negative 2 plus root 2, okay? What I want you to do right now is I want you to have a go of answering this question over here. If you're pretty confident of completing the square, then I don't really see as to how you would get any issues with solving the x-intercepts. So have a go, give yourself 3 minutes, and then we'll compare our answers together. So in this case over here, your first step is to get b, half it, and then square it. So therefore, it's going to be 9 on 4. Add 9 on 4 to both sides of the equation, okay? As you can see by this example over here, we've got a fraction, okay? And as I said, when we're trying to find the perfect square, it's always going to be this value here, whatever's inside the bracket. So in this case over here, it's going to be x minus 3 on 2 whole squared minus 9 on 4 plus 1. We're going to therefore add it together. Therefore, it's going to be equal to negative 5 on 4. In this case, again, it's always going to be equal to 0 because that's what the question is, but I've just left it out accidentally. Now we're going to factorize it in a difference of perfect square. So therefore, this is going to be your answer. Equate each of these factors to 0. So therefore, this will be your answer over here. So what I've just shown you in that previous example is how to actually solve it by using the null factor law. What I'll do now is I want to show you a different method of how you can solve it by using the square roots, okay? So in order to use this method, it's pretty much using the exact same approach as the visual method, okay? So the way this works is that the quadratic equation must have the constant, meaning the number on the other side of the equation. So in this case of here, once the equation has the constant on the other side of the equation, what you need to do essentially was that you needed to add in a term so that you can complete the square. And that term is always going to be b over 2 the whole squared. In this example over here, if you did that, then that would be equal to 1. So you have to add 1 to both sides of the equation. Once we've done that, then you can easily factorize the left-hand side, so your perfect square trinomial, that will be x plus 1 whole squared. And once we do up to this step over here, because we're trying to solve for x, we're going to square root both sides so we can isolate what x is, okay? So in this case, if you remember, when you square root a positive number, there's always going to be a positive answer as well as a negative answer. So therefore, it's going to be x plus 1 is equal to positive 4, or x plus 1 could equal to negative 4. And now all we do is just rearrange it to solve for x. So therefore, x is going to equal to 3, or x is going to equal to negative 5, okay? Let's go through another example of how to do this method. So if this was my equation over here, and I was trying to complete the square, first step is I want to try to remove the constant to the other side of the equation. So I'm going to add 11 to both sides of the equation, okay? If I do that, then this will cancel each other out because they're inverses. Therefore, this is what my equation will now look like. And now I'm going to add in b over 2 whole squared. In this case, b is equal to 6. 6 divided by 2 is equal to 3. 3 whole squared is equal to 9. So I'm going to add 9 to both sides of my equation. Why do I have to add it? Because an equation is balanced. Whatever I do to one side, I must do the same thing to the other side. Once you've done that, then you can actually factorize it as a perfect square. So therefore, this is going to be x plus 3 whole squared is equal to 20. Once I've done that, I'm going to isolate x by using the inverse, okay? So I'm going to square root both sides of my equation. So therefore, x plus 3 is going to equal to positive 20 or negative 20, okay? Now, I'm hoping that you guys still have some knowledge of how you can simplify surds. So in this case over here, because 4 is a perfect square, and this is the factor of 20 is 4 times 5, what I could do is, therefore, I could write that as 2 root 5 as shown over here. And now I'm going to isolate x by using the inverse. I'm going to subtract 3 to both sides. Therefore, this will be my solution. So finally, what I'm going to do is I'm going to use one more example, and I'm going to use both methods so you can see side by side as to what the similarities and differences are between these two methods. The similarity between these two methods is that you're still going to be introducing a new term. You're going to be introducing b over 2 whole squared, okay? So in this case, b is equal to 4, so 4 divided by 2 is equal to 2, 2 whole squared is equal to 4. So in both of these methods over here, I'm still going to be introducing this term. But for the very first method that we've pretty much familiar of, what we're going to do is we're going to add and subtract by 4 into our equation, okay? So if I've done that, this is what my new equation would look like, and therefore I can factorize the very first 3 terms because this resembles a perfect square. This will therefore be equal to x plus 2 whole squared minus 18, because negative 4 subtract 14 is equal to negative 18. And now what I'll do is I'm going to factorize this as a difference of perfect square. So therefore, this is what it would look like if you've done this successfully. And now what I'll do is that since this is equal to 0, I'm going to therefore use a null factor law to solve for x. So therefore, this is what your equation will look like. And then I'll just rearrange it to solve for x. And therefore, this would be my answer. So this is how we actually do it by using the null factor law. The second method, okay, which I'm going to show you over here, uses the visual approach, and then we're going to be using square roots. One of the main important differences is that in this case over here, we have to move 14 to the other side of the equation because we need to keep our constants on the opposite side. So therefore, that's one of the main fundamental steps. And then the next fundamental key difference is that you're going to be adding your b over 2 whole squared term to both sides of the equation, okay? So as you can see over here, I've added it to both sides. We didn't do so on the first side, okay? And in addition to that, the first method also requires you to subtract, but we're not subtracting for the second method. We're just simply adding to both sides of the equation. Once we've done that, then you could readily factorize this perfect square over here. So therefore, that's going to be x plus 2 whole squared is equal to 18. In order to isolate for x, we're going to take the square root of both sides of the equation. So therefore, this is what your answer would look like. And then you're going to subtract 2 to both sides of the equation. Therefore, you're going to get the exact same answer. But as I said over here, you can use whatever method you like. Just make sure you stick to one and don't mix up the steps together, okay? So have a go of answering this question, and you're free to use whatever method you like. But as I go through the questions together, I'm going to use both methods, okay? So give yourself 3 minutes and then compare our answers together. If you guys have done this successfully, the first step is to find out what is the b over 2 whole squared. In this example, that's going to equal to positive 9, okay? So therefore, I'm going to be adding and subtracting 9 if I'm using the first method. This would be equal to x minus 3 whole squared. minus 7 in this case. And now what I'll do is I'm going to factorize this as a difference of perfect square. So therefore this would be my answer. And I'm going to equate each of these factors to 0 and then solve for x. Therefore, this would be my answer over here. If I was using a second method, what I had to do is I have to move this 2 to the other side of the equation. So therefore, it will be x squared minus 6x is equal to negative 2. I'm going to now add to both sides of the equation b over 2 whole squared, which is 9 in this case. In this case, once I've done that, I'm going to therefore factorize this, which is equal to x minus 3 whole squared. Once I've done that, I'll square root both sides of the equation. So therefore, it's going to give you a positive and a negative solution. And now I'm going to add 3 to both sides to solve for x. Hence, this is going to be my answer. If you guys are pretty confident with factorizing by completing the square, then you shouldn't have any problems at all answering these questions. So I didn't actually give you that too many questions at all because it does get a bit repetitive. So answer questions 2, 3, 4, 5, and 6. This is pretty much the end of today's video. Hopefully you're able to now solve a quadratic equation using completing the square. I'll see you guys again in the next video. Bye.